Hey everyone, welcome back. Today we're doing shortest completing word. Given a string license plate and an array of strings words, find the shortest completing word in words. A completing word is a word that contains all the letters in the license plate, and we have to ignore numbers and spaces in the license plate and treat letters as case insensitive. If a letter appears more than once in license plate, then it must appear in the word the same number of times or more. For example, if the license plate is ABC12C, then it contains AB, ignoring cases, and C twice. Possible completing words are ABCC, DEF. In this case, AB in this case contains A and B once, and C twice in this case. For the second example, C appears twice, A appears more than once, and B appears more than once. We have to return the shortest completing word in words. It is guaranteed an answer exists if there are multiple shortest completing words, and we return the first one that occurs in words. So in this case, we have these words over here, and we have to return the first word in words, which contains all of these characters in this case. So we have to ignore numbers and spaces. So what this means is we have to find a word that contains at least one S, and we have to find one word that contains at least one P, one S, and one T. And in this case, S, the first word step contains S, it contains P, it contains T, but it doesn't contain another S. It requires two S's in this case, so the first word is not valid. For the second one, in this case, it contains two S's, and it contains one T, one P, and this is valid. So we return steps in this case. For the second example, we have S and just S itself because we ignore spaces and numbers. And for words, in this case, the first word that contains one S in this case, license plate only contains S, all the words contain S, but among these pairs still and show are shortest. The answer is pairs because it is the word that appears earliest of three. I see. This example was pretty helpful for me. I was under the wrong impression that we would just return the first word that contains all the characters, all the alphabetical characters in license plate. So this was a pretty good example. So license plate length would be from 1 to 7 characters. License plate contains digits, letters, uppercase or lowercase or spaces. Word length in this case for number of words that we have from 1 to 1000, and all words in this list range from 1 character to 15 characters, and words consist of lowercase English letters. So unfortunately, because we want to have the shortest completing word, if we were to iterate through words in this case to find any completing words, we have to go through the whole list, because it's possible that the word at the back of your words is really the shortest completing words. So the logic would be like this. Let's plan it out quickly. We will iterate through all words. Actually, there's one step before, one optimization worth mentioning is that for each character, we go through all characters in license plate. And to make it easier for us to look for characters later, we can keep track of a dictionary, store the alphabetical characters in a dictionary, and keep track of their count. So it will be something like this. For char in license plate, if char.isAlpha, in this case what this means is this is alphabetical, then what we would do is we would store it in a license plate dict. This license plate dictionary will contain every character together with their expected counts, and we will do license plate dictionary char. Actually, let's lower it first. Okay, so char.lower. Okay, lower char equals to license plate dic get lower char. Let's bring this left so that we have more space. And if the character doesn't exist, give it 1 and give it 0 and increment it by 1. So what we will get here is that we will get a dictionary containing the minimum number of characters along with the counts to be expected in a completing word. So we will use this to get the expected counts. And the reason why we want to do this is so that if we want to keep track of if you want to know how many characters we expect in a word, we do not have to go through a linear scan across license plate just to keep track of how many characters it has. That is going to be very expensive. It's going to be ON for every scan. So instead, if we use this dictionary over here, it'll be much more efficient because dictionaries are optimized for searching for a value by key. So now that we have this dictionary, we can iterate through all words. So for word in words, we would check whether if a word is completing. So we can abstract it as something like this. If is completed word, then we would add it into a final shortest completing word dictionary, I guess. Okay, let's see. Is there a way for us to keep track? Yes, I guess we can optimize this even further. We can keep track of shortest completing word. Let's set this to be shortest. Let's call this shortest length. And in this case, let's take a look at the... Okay, so words in this case can be up to 15 characters, right? So let's set this to 15, which is the longest it can be. If you do not wish to carry, you can just set this to a number that's pretty high. This will be overwritten anyway later. But in this case, just for clarity purposes, I'm going to set this to 15. And the shortest in this case would represent the string that is the shortest at the moment. So I'll set this to an empty string later, but this will be overwritten. So in this case, I'm curious if there's any test cases that would have no completing words. It might be possible, right? But since the function signature says returns a string, I would expect that there would at least be one completing word, so I would expect this to be overwritten. But if it is completed, then what we will do is current length. This would be equals to the length of word, and if current length is less than shortest length, then we would set the current word to be the shortest. So what we do is word shortest equals to word. So the idea is we will go through every single word, we check whether it is completed, and if it is completed, we would get the current length and we would override the shortest word with this current word if it is the current shortest word. And at the end, this is pretty much the answer. But the last part to this question is how would you implement is completed in this case? So this is just a final abstraction. So let's quickly define is completed. In this case, if we are given a word like this, we will return a boolean for whether it is completed. And let's just assume that in this case, this is a nested function. I will go through that in the implementation later. But for these words, for char in word, let's quickly do a simple, let's see, license plate dictionary. So now we have this license plate dictionary, and this license plate dictionary represents the minimum number of characters that a word should have. So one way to do this is to make a copy of this dictionary and use this dictionary to keep track of how many in a sense, the idea is for each of these characters in this dictionary, we need to reduce the counts to 0. And every time we encounter a character inside this license plate dictionary, we will decrement the count. And at the end of this iteration, for these characters in license plate dictionary, the count should be 0. So, but the thing is, unfortunately in Python, if you try to make a dictionary like this, like copy dictionary, and you set it to this dictionary over here, this is really a pass by reference. And that is, like, for our viewers who are new, you'll be like, what do you mean by pass by reference? What this means is you are assigning this variable over here to point at the same memory location as this variable over here. So if you try to edit this dictionary, you would end up editing the original dictionary, which is not what you want. So instead of just assigning this variable to the original dictionary, we must do something called a deep copy. So frankly, I need to do a little bit of Googling. It's been quite some time since I did that. So let's Python how to make a deep copy of a dictionary. If I'm mistaken, you must import the deep copy library. Yes, this is the one. Oh, sorry, the copy library. So it would be copy.deepcopy. And as you can see, the deep copy takes in a variable, the variable that you want to copy. And once you do that, you'll get a deep copy of this dictionary. So let's quickly do that. Let's import copy and let's do copy.deepcopy, and we pass in the license plate dictionary. This way we will start off with a fresh license plate dictionary every time. So we will do for character in word, if let's get the lowered character, because the copy dictionary here contains only lowered characters, just like what we did over here. So lowered character in this case will be equals to copy dictionary dot get. Copy dictionary, sorry, I'm confusing myself here. We just have to lower the character here, and now that we have this lowered character, we can decrement the copy dictionary by this. So if lowered char in copy.dic, then copy.dic minus equals 1. Okay, and actually let's make this simpler, and copy dictionary dot get, sorry, just lower char is more than 0, then we will decrement it by 1. And the idea here is, if we find a character that is inside the license plate, we will decrement it in this copy dictionary. And after we iterated through this, okay, another thing that we need to check for is if char.isAlpha. We are only concerned with numbers, with characters that are alphabetical. So after this is done, we will iterate through all the items in copy dictionary, and by any chance, if there are any characters that are still more than 0, then what this means is this word is not completed. So we will do for char and count in copy dictionary.items, if count is more than 0, then we will return false, otherwise return true. And that's pretty much it. This is pretty much the logic for is completed. Yeah, I guess I shouldn't have coded it out when I am planning it out. I guess it's more for understanding the general approach, but it's okay. Let's just go ahead with this. So now, unfortunately, since we have already coded it out, let's just paste this here. And this is pretty much the logic over here. So let me remove this since we have it. Let's iterate through all the words. Okay, so this is for going through all the characters over here. So let me copy this and leave a comment over here. Okay, the second part, after we saved all the characters in license plate into a dictionary for easier tracing, the next step is to iterate through all words. So just like this. And we iterate through all words to get the shortest word. So at this point, we should get the shortest word. The last part is to implement is completed over here. And is completed in this case is this nested function that we define over here. And this is completed over here. Okay, let's leave a comment here. Checks if a word is completed. That's all. i.e. contains all alpha characters in license plate. And once done, we get the shortest completing word in words. Let's copy this and paste it here for easier readability, I guess. Yeah, let me just put it here instead. Okay, looks great. So now let's try tracing this out with a sample test case to better understand if this works. Okay, let's use this test case here. And in this case, license plate is 1s3 pst. So let's get started. So we are iterating through all characters in license plate now. The character is equals to 1. Because 1 is not an alphabetical character, so we will skip this. Let's go to S. S is alphabetical here. We lower it. So lower char is now S. And we update license plate here. So let's use a multi-line command here to keep track of license plate. S, and now it's 1. Okay, so we continue. Now we have 3. 3 understandably is not an alphabetical character, so we skip it. Same for the space. Now we have a capital P, lower it, give us P, and we update the license plate with P equals to 1. Now we'll continue. Capital S, this gives us lowercase s, and we put S here. Sorry, in this case we already have S here, so it's 2. And let's do T. T in this case will give us lowercase t, and we will put T inside this license plate over here. So now we are done with populating our license plate dictionary. This will be used in the bottom part of the code. So now we are here. Like, functions are lazy, so I will trace this once just to show you how it works. But let's start off over here. Like, we skip this because functions are lazy. It's not going to be executed until we call that function. So now, shortest length is now equals to 15. Shortest is now empty string. This would be overwritten later. And this is the first word. Word is equals to step, right? So step. And now we're going to check whether the word step is completed. So let's take a look over here. Now we make a copy of license plate dictionary. So copy date will be equals to this same expression over here. And as we discussed, overwriting this dictionary over here would not affect the original license plate dictionary. So now for every character in Word, let's take a look. So now the current word that we're looking at is step. So char equals to S. And to make it clearer, let's put the word over here. So character is alpha, lower character is S, and lower char is in the dictionary, and copy dictionary lower char is indeed more than 0, so we decrement it by 1. So now this is like this. Now let's take a look at T. T in this case exists as well, and the count of T in copy dictionary is indeed more than 0, so we decrement it. Now we have E. E in this case doesn't exist, so we don't do anything. And now we have P, and P exists in copy dictionary, and the count is more than 0, so we decrement it. And now we go through all characters and counts in copy dictionary. Thinking about it, I could just make these values. We're not going to use the key anyway. So in this case, the first count is equals to 1. I guess for tracing purposes, you can leave it there, but you can see that we're taking a look at the first character. So because the count is more than 0, we'll return false. So is completed in this case would be false. And we would skip all this stuff here. Now we'll move on to the second word, steps. And you can see that we would do the same thing as we did over here to check whether if the word is completed or not. In this case, this will pass because steps has a final S, right? So we traced it out to this state with step. So if you have an additional S at the back, this final S over here would set this to 0, and this would return true in this case. I skipped a couple of steps, but if you trace this out, you will see that is completed for steps would be true. So in this case, the current length of steps is 5. So we would set the shortest length to 5, and this would be steps over here. And we would have one answer over here. We will also have stripe, we have staple, but you can see that both of these words are longer than the current word that we have, and we'll end up with steps as the answer. So that's pretty much it for this approach. Let's do one final check to see that everything is fine. Looks great. I'm tracing over here now. So we go through every single character in license plate, lowercase it, and update it into the license plate dictionary. We keep track of the shortest length. We go through all words. We check if each word is completed, and if it is completed, we get the shortest word inside shortest. And the bulk of the implementation is completed. We check every word if they are alphabetical, we lowercase it, and we decrement it in the copy dictionary over here. And after we go through all characters in the word, we check the copy dictionary, which represents the remaining characters that should have been set to 0. And if any of these characters are not present or not used up yet, we return false. Otherwise, return true. Quite a little bit of a mouthful, but I hope that this tracing makes it clearer. Let's run this against some sample test cases. This passes, and let's submit this. Okay, wrong answer. Why? Show passed. Oh, okay. The answer should be passed, but we gave show. I guess the reason is because we want to return the first one. The first one that occurs in words. I see. Interesting, but this shouldn't have happened actually. It should only be because we only override it if the current length is less than the shortest length. So what this means is if two lengths are the same. Oh, I see. I forgot to override the shortest length with the current length. Yes, that's why I missed it out. And as you can see, tracing is not always impactful. But anyway, yeah, this is a good attempt. And let's quickly go through the time and space complexity of this approach. So we use a license. Let's go through the time first actually. Time complexity. And for formality, let's let n be the number of characters in license plate. Let's m be the number of words in words, and let p be the number of characters in each word in words. So let's go on. So over here, we go through all characters in license plate. So in this case, this is going to be ON. And let's make the assumption that we're talking about the average time complexity of getting a character from a dictionary over here to be O1, and updating a character in a dictionary to be O1 as well. Average time complexity. So in this case, let's just take this as O1 for each iteration in this for loop. So let's say the time complexity for this statement of updating the license plate dictionary as ON. Now, let's also take a look at is completed. In this case, the copying of the dictionary, in this case, would be, in the worst case, your license plate dictionary might contain all unique characters in license plate. So what this means is the copying would be ON, because you have to go through all ON unique keys and values to copy into this dictionary over here. So this copying, unfortunately, is very expensive as well. So let me remove all these workings here, I guess. So these statements over here are going to be, these iterations over here, for every iteration in the for loop, is going to be O1 average time complexity. And just for information, like, we are talking about worst case, but to simplify this worst case time complexity analysis, by right, getting an item from a dictionary is ON if the dictionary is really large. But in this case, to simplify just for the dictionary analysis, we're going to say that average case time complexity of getting an item from a dictionary is O1. So let's take it as O1 in this case. So in short, all of these iterations, one iteration over here, let's say that is O1. And since we're iterating all characters in words, in this case it's going to be OP, because P is the number of characters in each word. So for count in copy dictionary value, once again, if the dictionary contains unique characters in license plate, in this case it's going to be ON as well. Worst case, ON. So this, in short, the time complexity of is completed would be O2N plus P, but if you remove the coefficients, then this is going to be N plus P. So this looks great. Okay, let's use this. And is completed is going to be used in the for loop below. So let's continue. So for in words, because we're iterating through all words in this case, since the number of words is OM, this is going to be OM already. And is completed, as we discussed, is ON plus P. And all of these iterations over here are constant time, so it's fine. In summary, this is going to be OM N plus P. So if we OMN plus ONP, if we multiply them together, it's going to be like this. Let's just, okay, so this will be OMN plus MP. Yes, so looks great. And in summary, the time complexity is ON plus OMN plus OMP, like this. I guess you can just make it simpler. This would be more readable, I guess, versus multiplying the coefficients together. But in summary, if we remove the lower powers, the time complexity is going to be OM multiplied by N plus P. And now let's take a look at the space complexity. In this case, let me remove all coefficients, all comments that we left for the time complexity analysis, so that we don't confuse ourselves. Let's continue. Now let's take a look at the space complexity. Because we populate license plate dictionaries with all characters in license plate, alphabetical to be sure, but in the worst case, if license plate consists of only alphabetical characters, then the license plate dictionary can take up to ON. So you're going to use ON space over here already. In this case, under is completed, for every call, we are making a copy of license plate, so this is going to take up ON as well. But fortunately, is completed is going to free up the memory after every call, so it doesn't scale linearly with the number of words. So this looks great. Yep. So is completed use ON. Sorry. Is completed use ON. And this is constant across all iterations. So let me just put it at the top level perhaps so that it's clearer. And shortest in this case also uses memory. The rest uses memory as well, but since they use constant memory, I'm gonna avoid it. But the shortest in this case is going to be OP. Shortest is going to take up the shortest. It's going to contain the shortest word. So this worst case time complexity of OP for shortest is very pessimistic. It's very likely that shortest would contain a very short word, but let's just put it as OP. And since the for loop uses is completed, it's going to be ON. And that looks great. So in summary, the space complexity would be ON plus OP plus another ON. So just O2N plus OP. And in this case, because we're going to remove all coefficients, so the space complexity will be ON plus OP, or rather ON plus P. And that's about it for this demonstration. This turned out to be more complex than I thought, but I hope that this was a good demonstration for this algorithm over here. So if you like this, please give us a like and subscribe, and we will see you in the next video.